Okay, we're going to go ahead and get started here. Hello and welcome to today's webinar, Sending and Receiving Triggers in ePrime. My name is David Nicholson, and I will be your presenter today. I'm accompanied by Laura, who will be assisting in answering any questions you may have. Please direct all questions to Laura on the Psychology Software Tools account. Laura and I will answer the questions periodically during breaks and at the end of the webinar in the Q&A section. In ePrime, port communications allow you to interface with an external device that connects to your parallel port, socket device, or serial port. Generally, the signal can be sent before the object, at the onset of the object, or following the object. While ePrime is capable of sending signals to the port for interfacing with an external device, the receipt and handling of the signal by the other machine is the responsibility of the user. With the write port command, ePrime may be used to trigger an event, such as a signal to an external device to begin data acquisition or notify an external device of an event, for example, in order to mark the event in the data collected by the external device. Now first, I'm going to go ahead and open up a blank experiment here. You can open your experiment, eStudio, by going to Start, All Programs, ePrime 2.0, and then clicking on eStudio. And while this loads, I'm just going to go ahead and select Blank Professional, and we'll flatline that for now. Now before we begin, I'm going to show you how to find the port address for your device. We can do this by looking in the Device Manager. There are a few ways you can get there. One is clicking on Start, go into Computer, right-clicking, and selecting Manage. And then this will bring up Device Manager, which you'll see here. You can also access it in the Control Panel by selecting System and then clicking the Hardware tab. Now to find the ports, once you have a parallel port or serial port connected and the appropriate drivers, you should see this ports column right here. You can click that to make the drop down, and you'll see I have a prolific USB to serial COM port adapter there. And to find that, if we go to these properties right here, you can either double click it or right click and go to Properties. You can see that this is currently on COM 7. Now if you had a parallel port device, this would be in the same location. You might have to do things a little bit differently in your experiment depending on which version of ePrime you're currently using. If you have the latest production release of ePrime 2.0, you can use the LPT number, which I have some screen captures here from another machine with the parallel port. So here you can see the same drop-down that we're in before, and the parallel port is listed as printer port LPT2. And then if we would right-click and go to Properties there, you'll see a similar screen would come up before like it did for the serial port. Now if you click on Port Settings, here you could change the LPT number. So if you have a conflicting number, you can change this here. And then if you click on the Resources tab, you'll see an I/O range. And it's set to the default here, which is 378. And this is a hexadecimal number. And depending on which method you're going to use in ePrime, either a port or parallel port, you would either put one or the other depending on which device you're going to use. So if we go ahead and open back up the blank experiment here and double click on the experiment object, the experiment object property pages will open up. Now if we go to the Devices tab, you'll see that by default the display, keyboard, mouse, and sound devices are added to the experiment and enabled. Now to add a parallel port device, we can click on the Add button, and then you'll see both parallel port and port. Now if we look at the parallel port device and then highlight it again and click Edit, you'll see here this is where we can set the properties such as the LPT number. And previously we had it on LPT2, so you want to match that setting. And everything else by default should be the same depending on the hardware you're connecting with and what your other software is expecting. But you can refer to the documentation for that software to find what the recommended settings are. And you can also specify if this port should be set for input or output. Now, if you have an older version of ePrime 2.0, you'll have to use the port device, and that's why I showed you where you could find the I/O number, which is in hexadecimal. So here, instead of using an LPT number, you have to enter the hexadecimal address, which will use the ampersand H, and then it was 378. You could also use this in decimal if you converted it, which would just be 888. And you can see the rest of these settings here are the same. Now, if you had a machine that didn't have a parallel port but still wanted to facilitate parallel port communications, on a desktop machine, we recommend purchasing a PCI or PCI Express add-on card. You can find these cards on many computer hardware retailer sites, such as Newegg or Tiger Direct. We do not currently recommend specific PCI or PCE Express adapters. However, we have seen good results from SYBA, SIIG, and Sonix chips. If you have a newer laptop with an Express card expansion slot, we suggest you use Qualtex SPXXP 126-pin parallel Express card. And if you have an older laptop which still has the PCMCIA expansion slot, we have a specific model that we recommend for that as well from Qualtex. And you could find more information on the recommended cards that are compatible with ePrime on our support site. So if you open up your web browser and go to pstnet.com, and then you'll see the support tab. And if you look under our ePrime knowledge base, and we can just type in parallel port here. And we'll see we have recommended parallel port adapters for machines without parallel ports. And more detailed information can be found here, what we recommend for your machine. Now, there are other cards on the market that are similar to the serial to USB adapters that go USB to parallel, and these type of adapters will not work with ePrime. It's important to note that USB to parallel cables, since they don't have access to DMA, which is direct memory access, like the parallel port does, it's unable to use the correct drivers there for it to work. It'll show up as a Microsoft USB printer driver, which is designed for only supporting printing. Now moving on, ePrime also supports socket device, which if you go back into the experiment object devices tab and click on add, you'll see the socket device, which is essentially the Ethernet port. And if we go into its properties, you'll see that you can enter a server name, port number, and for the connection type, there's TCP and UDP. The production release of ePrime 2.0 supports both TCP, IP, and UDP connections. And the production release, you can add the socket device like I've shown in the property pages. And this will allow you to specify the settings for the socket device directly on the experiment object instead of having to do this all in inline scripts. Just a few notes about UDP. By its nature, it does not guarantee the delivery of packets, and if a packet is delivered, the delivery is not guaranteed to be in the correct order. UDP is faster, but it does not guarantee that intended data will actually be sent, whereas TCP is slower, but guarantees the data is received. UDP is connectionless state. If you are using UDP, you must be prepared to handle missing datagrams, duplicate datagrams, or a datagram in the incorrect order. You must also handle for error detection and correction, which that should be done in the software that you're connecting to. If you use a crossover cable for a direct link, or use a switch where the only two machines are the ePrime machine and the socket server, you in practice will have minimal issues with UDP. And it also is a good thing to note that currently it is not possible to both send and receive signals via socket communications and ePrime on the same machine. Because the nature of the socket device and how each machine must be set up to allow for either sending or receiving, the machine can only communicate one way. For experiments where sending and receiving between two machines is necessary, we recommend serial communication. Now, if you are using a machine which doesn't have a serial port, like the current machine that I have, we recommend using a DB9 USB converter, and that'll work for all serial communication devices. We have confirmed that these adapters do work with our SR box and FOBRS and ePrime and provide accurate timing even on the slowest machines. You do want to make sure that you have the latest drivers for this machine. For the USB to serial adapter, you can find that by using Windows Update or going to the manufacturer's website. Now you can see on my machine currently, I'm using a prolific adapter, and it's set on default by COM7, which just got assigned there when I plugged it in. Now if you go to its properties by double-clicking or right-clicking, go into properties, and then selecting port settings, you'll see that these are the settings here by default, which are just fine to leave by default. If you can modify these in ePrime itself. Now if we click on Advanced here, you can see that I can actually change the COM number, which is useful because if you're using ePrime 2.0 standard, you're only allowed to use COM 1 through 4 when accessing the serial device or SR box in ePrime. ePrime 2.0 Professional allows from COM 1 to 256 when accessing the serial device or SR box. So this would be fine leaving on COM 7 if we were using ePrime 2.0 Professional. If you were using standard, you would want to switch this to COM 2, which was the only one that was listed as being open. So I went ahead and applied that there, and you can see that now my COM port is listed as COM 2. And to add the serial port to the experiment, we can go back in there and double-click on the experiment object, go to the Devices tab, click on the Add, and click on the serial. Now if you select it again and go to Edit, you'll see by default it's listed as COM port 1. We just changed it to COM port 2, so you'll go ahead and match that. Now if you are just connecting to a SR box, you would most likely want to just use the SR box here. If we look at its properties, you can see that the baud rate and everything else is set properly there for that device. The only thing you would need to change in this case is the COM port number and changing that to 2. Now before we get into actually talking about sending signals, does anybody have any questions about basically just setting up your basics here and getting all your ports set up correctly? All right, awesome. Looks like we're good to keep going on. Now that we have everything configured for a device, we need to send a signal. The easiest way to do this, to send a trigger to an external hardware, is by using the new Task Events feature. Task Events expands ePrime 2.0 Professional synchronization capabilities by offering a wide variety of options to take action when specific time-critical events occur during an experiment. These capabilities, which were either difficult or impossible to perform in the previous editions of ePrime, can now be achieved using eStudio interface, relying less on complex design or advanced eBasic scripting techniques. Task events can be thought of in terms of cause and effect, where the event is the cause and the task is the effect. I'm going to minimize this experiment here and minimize this as well. In the files I sent you, you should have got one of them called Basic Triggers. And in this event, in this experiment, I went ahead and set up a few task events here, but we'll go ahead and add some more as well. Now if we double click on this stimulus object, select its property pages, you'll see that there's a task events tab. And this is where you'll add your task events to the experiment. You'll see here I've already added things for the stimulus onset time and for the SR box as well. So we'll go ahead and close out of this. Before you can send a signal to a task event, to an external device, you need to add the actual device in the experiment object, devices tab. And you see for demonstration purposes, I've added the SR box, parallel port, and serial device to this experiment, just to demonstrate how you'll see everything here and what options are available between each. We can go ahead and press OK here. Now the configuration of a task event is performed via the task event property pages, which were at before. And when using the task event, the first decision is to choose which event should be listened to for the trigger at the beginning of the task. This is the cause. Now to add a task here, we would click Add, and you'll see all the available options we have. So if you wanted to send something at the offset of the stimulus, you can select it, and then press OK, and you'll see that it's added on here now. Next, we need to choose the task event, which will generate the response. So what we need to do here is we need to select the task, and let's say we need to send a signal to a parallel port. We can select parallel port and press OK. Currently, the supported objects are parallel port device, socket device, and serial device for the task event. And now you'll see that we have this delay box is no longer grayed out. So this would be useful, say if you did have the onset and we send a trigger of high to a pin, and then later on, let's say 10 milliseconds later, we wanted to take that pulse and put it back down to 0. We can go ahead and set a delay for 10 seconds here, so that way we're sending already an onset of a high pin, and then we can go ahead and reset that pin in a delay of 10 milliseconds. But for right now, we'll just leave this at 0 since I selected the onset time. Now if we go to action here, you'll see the options are reset bit, set bit, toggle bit, and write bit. Now these are going to vary a little bit between which device you're using. The reset bit will reset the bit from high to low as specified in here. So if your bit is already set to high, it'll switch to low, and vice versa. The set bit will, I'm sorry, I think I got confused. The set bit will set the bit either high or low depending on what you specify. The toggle bit will specify either high or low and switch that depending on what state previously is. And the reset bit will obviously just reset the bit from high to low. If the pin's already low, it'll continue to stay low. And you can also write a byte, and that will basically just write an array of bytes to your device. I'll go ahead and just select write byte for right now. And you'll see here that the source is custom, and the options are custom, timestamp, and timestamp micro. Timestamp would just be the time when this occurred, and timestamp micro would be a condensed timestamp. But if your external device can only accept integer values, you might not want to use this because you're most likely going to run into an overflow. But for right now, we'll just send a custom value to this, and this can be useful. You could send attribute references, so, or even a correct response here. And you'll be able to select long, integer, or byte. Generally, if your application can accept a long value, you want to go ahead and use that. If you're using an integer value, you can easily run into an overflow because of the numbers greater than 1,727. Then you'll hit an overflow there and an error will occur. If your external device is capable of receiving a long, we always recommend using that because that number can be up to over 2 billion, and chances are you're not going to send anything larger than that. Now, once we have all this chosen here and selected, leave this source code here. Basically, you would just set everything. We'll just send an arbitrary number for right now, 3, and set this to long. And this would send a 3 at the onset time of stimulus. I already had this here before, but we can just go ahead and remove that. Something more practical to do in this situation, since in this task event, let me go back in here, I had a write byte of 0 at the stimulus onset, and then for the stimulus response, which was from the SR box, I'm going to send the response, which would either be a 1 or a 2, which would be like in the duration input tab. You'll see my allowable is 1 or 2. So this will send the response to your external device. Now, it's always good to clear your device and settle your pins below before receiving a new bit of information. That way that can prevent any kind of errors from the values summing up together in your external equipment if there isn't enough time for your hardware to register the changes. There is a fail-safe and some parallel port cards that if you send values repeatedly fast, like with a 1 millisecond delay, it'll just return the launch trigger. So it's always a good practice to put about 10 milliseconds between each trigger pulse. So what I would recommend here, you'll see in trial list, we have 4 samples with a weight of 2 and 2 for a total of 4. And all we're doing here is just pressing a 1 for X and a 2 for Y. And it's referencing a nested list trial num list. And this list is just in sequential order 1, 2, 3, 4 to show our trials number. And this can be used to send a nice identifier to your external equipment. That way you can easily track which trial you're on, and it'll make your data much easier to analyze and read. So on the fixation slide here, we go to its property pages, and then click on the task events. Now you'll see here on the onset time, I have a delay set to 0, and I'm writing a byte of the attribute stim num and the data type long, and that will be whatever we have set here, which would be a 1, 2, 3, or 4. So each trial, it would send a unique value to your external device, and that'll give you a nice marker of which trial you're on. And then following in the stimulus object and its property pages, task events tab, you'll see that at the stimulus onset, I clear the port, and then for the response, we send out a 1 or a 2. And that way, you'll have just basically a constant set of feedback there, collecting data, sending it to your external device without having to worry about any kind of errors or numbers jumbling up together there. So that's just a good practice way to do that. And the same thing can be applied to the serial device as well. You saw earlier that I did add the serial device to the experiment object. And I'll just demonstrate what are some differences here between the parallel port and the serial port. So I'm going to go ahead and change this to serial. And you'll see that the actions now are write string, write long, write integer, and write byte. Obviously, these ones are kind of similar as the parallel port before, either writing a long value, integer value, or a byte. The only difference here is the write string, and this will actually write a string to your device. So this could be anything from an actual response, like if you would use the response that they typed in or anything like that, you can use this. Or if you even want to send the name of an object or a list, if your external equipment is capable of handling string data, you can go ahead and send string data with the serial device. And the socket device is also similar to this. I don't believe I have it added to this experiment, but it does use the same commands as the serial device. So that would be pretty much the same there. And a good reference is eBasic Help, which you can always go to Help and then eBasic Help. So let's say if we did want to look at the socket device, you can just type in socket, and then you'll see all of its available options there. I'm going to go ahead and close this for right now. So basically, using task events, it's an extremely simplified way of sending triggers to an external device without the need for any use of inline script. You can delay triggers if necessary and send them when you need to, as opposed to using inline script, which we'll get into in a little bit. It could be a little bit more involved, but you definitely can accomplish it both ways. Before we move on to using scripting for sending triggers, do you have any questions about using task events?
Looks like no questions so far, but of course, if anyone has any questions, we can always answer them at the end of the webinar, and just send them to me here in the questions tab.
Okay. Well, if you do need to use script to send triggers to an external device, or if you're using ePrime 2.0 standard, the task events feature will not be available to you. Or if you're using ePrime 1.0, task events is not in that version either. So your main, your only option here would be to use inline script.
Actually, David, I did have a question here.
Oh, yes, I'm sorry.
No, that's okay. The question is, can you send a string to external software?
Okay. Yes, you can actually send a string to external software. If that string would, say, be the response here, so if we look in the stimulus object property pages, duration input tab, this would be kind of a bad representation here, but I'll go ahead and just add a keyboard device, and you'll see that they can type in anything here. So say if they typed in A, or if you increased your max count, so they typed in a sentence or anything like that, we can actually use their response data. So it would be stimulus.resp, and that could be sent, we'll add another one here, let's say to, we'll just choose offset for right now, and select the serial device. And in the serial device, you'll see it has write string. And then it has custom, timestamp, and timestamp micro. You can go ahead and leave this at custom. And here you would actually be able to specify, stimulus.resp, and that will allow you to send whatever value your response was as a string to your external device. And naturally, when you are specifying any kind of attribute reference, you want to make sure that you put brackets around it as well. And then it'll turn blue, so that way you know you're referencing an attribute. I'm going to go ahead and cancel out of there. All right. If you need any further clarification on that or how to send a string to an external device, we're going to be covering that a little bit more later on when using inline script for the serial device. Or you can always direct any questions to Laura, or even create a support request on our web support site at pstnet.com//support. Now, like I was saying earlier, if you're using ePrime 2.0 standard and you need to use inline script to send a trigger to an external device, you can either use our script we have here in eBasic Help, or if you like, you can create your own DLL, which is a bit more complicated. Now, if we go to Help, eBasic Help, we can pretty much type in any device we want to send a signal to find out more scripting examples for it and more information about it in general. So we'll start with the parallel port here. And you'll see that the parallel port device shows up. And we have read current byte and write byte. Now the parallel port device is different than the port device. Like I was saying earlier, that'll just depend on if you're using an LPT number or if you're using the actual I/O number for your device. Now, as we talked about before, we would find our port device for our parallel port. I'm just going to open up these images I had before by looking in the device manager, which can be found in the system from the Windows control panel, clicking on the device manager tab and navigating to ports, selecting the parallel port, which is LPT or printer port, clicking the properties button and selecting the resources tab. And here you'll see the port address in my instance is specified in a hexadecimal notation. Like I was saying earlier, when using a hexadecimal notation, you need to use an ampersand followed by an H and then the port address to be inserted prior to the address. For example, the most common parallel port address in decimal is 888, which translates to the ampersand H 378. In your experiment object property pages, devices tab, we go ahead and add the port here and go into its properties. Like I was showing you guys earlier, you can either put 888 or the hexadecimal value. Either one will work for you. The value will be translated into binary notation either way, so it will work. The bit pattern then corresponds to the pin connections, and the bits are either 0-based or 1-based, and pins are always 1-based. Now you must remember that when you're writing to the parallel port and you are sending 8 bits of data at once, you will write a number like a 1 to any bit whose corresponding pin you wish to turn on, and a 0 is written to any bit whose corresponding pin you wish to turn off. Bit-to-pin mapping is relatively standard for the parallel port. You can look at documentation for your specific hardware and parallel port card for mapping of bit-to-pins. Generally, the first available bit-to-pin connection begins at bit number 1 and at pin number 2. You cannot send a signal to pin number 1 in EEPROM. With the standard parallel port, you can assume that pins 9 through 2 correspond to the number of all zeros when the pins are off and match the values with the notation. Using the binary system, that number value of the pins 9 to 2 are 128, 64, 32, 16, 8, 4, and 2. Want to send if you wanted to turn pin 9 on, you would need to send a value of 128 to the port. And a more specific breakdown of this can be found on our web support site. So if you go to pspnet.com/support and then select knowledge base, and it's actually right here. If you go to general parallel port information, you'll see that we have a breakdown of the actual pin values here with the table and a more specific information of the connectors if you're needing to look at that. Occasionally you will have to configure your parallel port to your machine. This can be done in your BIOS, or you can also use our sample located here, which is parallel port configure, and that will allow you to set your base address so you can both send and receive via the parallel port to your external device. I actually included a similar sample. We open up basic port RT. and we can just go ahead and maintain this in standard format. For these experiments, since they are not using task events or any features that are professional, I decided just to create these in standard. You can go ahead and convert them if you wish. That'll just enable other features that you have available to you. Now in this experiment, you can see that there's a good amount of script going on here. Now if we go to View and then Script, which is already open, you can see that we have set a base address here of 888, which is the hexadecimal number 378, which we looked at before. And for the out port, it's set to the base address, and the import address is the base address plus 1, so 889. And this is simply just turning on two lamps, a red and green lamp, on and off. If we look in the experiment object property pages, and then go to the Devices tab, you'll see that we have the port device enabled here. If you select it and click Edit, you'll see that the address we have here is 889, and that is the device that was set up for the input there. And the inline flash lamp, the write port command is used to write the value of 255 followed by 0 to turn all the pins on and then all the pins off. And this is the loop until the instructions slide starts here. Generally, properties that we're looking at in here, you really only want to set these properties once per experiment. You can do it at the beginning in the user script, or you could actually even do it later on in the top of the session proc if you need it. Now you want to use the write port command inline, always followed by 0, and that would do something similar that we did before, and that would just make a TTL pulse of setting all the pins high and then resetting them back to low. So then they're able to accept the next input you're wanting to send out from them, so they're not still all either turned on or turned off, because that could prevent some signals from being sent. For instance, if you have pin 2 high and then you try to send another signal through pin 2 again to turn that one high, if it's still high, your signal will not go through and it'll just kind of show up as blank on your external device since the pin is already set to high. Now if we go down here to turn all off, you'll see that all this is doing is just making sure that all of our lamps are off, and that was the green and red lamp, and this is to occur before the fixation here. And this particular experiment presents this subject with a fixation and then a stimulus X or Y, and the subject is to respond by pressing the button on the device when the X is presented. When the Y is presented, the subject should not respond. The input is scored for accuracy and reaction time. If we look at the stimulus property pages, duration input tab, you'll see that it's collecting data from the input mask from the port device, and the allowable is 7. And then to send this response out, and the inline score, if the accuracy is correct, we turn the lamp on and send that out with a 200 millisecond sleep, and then we put the ports back down to 0 so it can accept the next response. And then finally, at the end of the experiment, you should always make sure everything is set back down to 0. If you leave pins high, it is possible if you run the experiment again that these pins will still be left high. This can cause issues with initiating a device and with receiving the correct signals during further runs of the experiment. Now, besides the write port command, generally the nice thing you would want to do with the parallel port is to use onset signals and offset signals. These properties allow triggers to be sent at the exact time of an object onset or offset, and will greatly improve your ability to keep timing consistent with stimuli. So as you can see here with these current ones, it's occurring after this feedback object, and then these sleep commands here, which will show up as onset delay for your next object. Now, if you need to find more information about the parallel port, we can look back in eBasic Help by going to Help, eBasic Help, and type in port. There we go. And locating the port device, which took me a moment there. And here about the port device, the information that it can send and retrieve. And it may be a little confusing to navigate your way around here at the moment. The onset signal and offset signal commands are actually under the RTE runnable input object, which that is what the port device derives from. We are working on updating our eBasic Help documentation here, and that will be released shortly. So it'll be a little easier to navigate around here. But generally, if you do search for something, you should be able to find it where it should be at least right next to it in the order. And in this example here, you'll see that this has the default value of LPT1 for the port. And what it's going to do here is, at the instruction slide, it's enabling the onset signal, which is set to true, and the offset signal as well. And then you have to assign your port for both, which in this case is just using the default of 378. And then here it's sending values. You can also just use decimal values here, so you can put 0, and I don't know off the top of my head what FF is in hexadecimal, but you can also use hexadecimal or decimal values there for your onset and offset signal data. The onset and offset signal properties direct E' to internally send a specific value to a specified I/O port. So that's useful if you're using a device that has an I/O range but isn't technically listed as a parallel port. So you can use a port device in that situation and still be able to use the onset signal and offset signal. The I/O port used is typically a parallel port, but a digital I/O port rather than a serial port. Each bit within the port has some assigned meaning by the researcher. For this type of signaling, you can typically use the built-in parallel port, or alternatively install a register addressable digital I/O card. If you use the default parallel port, there is typically no hardware initialization needed. If you need to use third-party digital I/O cards, you often have to configure the card once at the beginning of the experiment, like I demonstrated in the example, and use write port eBasic commands to send values to the configuration value to the designated configuration port. This step typically programs and registers ports on the card as input or output. You can refer to your card's programming manual for specific instructions on this step. And that's pretty much the main difference between the parallel port device and the port device. now socket communications, which I included a sample for, those can really vary with the support of UDP and the production release of ePrime 2.0. There is really a lot more available you can do with it, but ePrime still can really only act as a client machine. The commands for the socket device are nearly identical to the serial device, so I won't really go into detail about the socket device. I have included a example experiment that you should have received with the socket device, so you can go ahead and look at that one further if you need more information on that. You can always contact us as well at our support site or reference our knowledge base for more information on the socket device. I'm going to go ahead and flatline this experiment and open up basic serial RT. And once again, I'm going to just maintain this as standard ePrime 2.0 standard. Now, similar to what we had to do before, first you'll always need to find your port number, which would be in your device manager ports tab, and then you can use your COM device here, which we switched to COM2 earlier. Now if we go to the experiment object property pages, devices input tab, you'll see that the serial device is already added here. If we highlight it and select edit, you'll see that it has COM port 1 set by default. So we would need to go ahead and change this to COM port 2 to match our current settings on our machine. And then press OK. In this example, the ePrime program waits for a signal from a device connected to the serial port. Then it runs the trials. During the trials, the response is written to the serial port. So if you look at wait for serial input, you'll see that serial device is waiting for the input from the serial port. And then in write serial, it's actually sending the stimulus response out to your external device. And the stimulus response would actually be a string value. And that's why we're using rate string here. So that kind of goes back to what you were asking about earlier of how to send a string to an external device. And this can be accomplished using the serial device. And for more information of the serial port, you can once again use eBasic help. And we'll just go to the serial device object. And you'll see a list here of all the available commands you can use. So, for instance, we're using write string. Then you can see the parameters that are required there for it to run. I guess the main method of sending triggers using the serial port is using the write string command. It is a good thing to note that this method will not guarantee that the signals are precisely synchronized with the stimulus, since you can't use onset sync and offset sync. But this would occur immediately after the feedback device. I actually think this might have some pre-release on it. If we look into feedback object, property pages, duration input tab, we can see that pre-release here is set to 100. So that pre-release will actually 100 milliseconds of processing to occur on the next object if it's finished loading, which it definitely will be by 1400 milliseconds. And that will actually allow this trigger to be sent while the feedback display is still being shown, and that will prevent you from having any onset delay to the next fixation. To enable a write string pulse that is sent before an onset of an object, you would use basically similar to what we have down here on the right string, but you would just go ahead and add an additional inline, which you can just drag over here. We'll put it before the fixation and open that up. And you could either rename this by right-clicking, go into rename, or by pressing F2. And here you can pretty much add whatever you wanted to in there. If you just wanted to send, for instance, the trial number, you can send that as well with the right string. So basically anything that you would want to send as a string value before the onset of fixation, it would just be serial, right string, and then whatever data you'd like to specify there. So for instance, even if you'd like to specify which list this is coming from, you could even just send the name of the actual list itself. This does assume that the serial device is added to the experiment and that the serial communication properties, the port ID, baud rate, start bit, parity, and stop bits, etc., are configured the same on both machines. So you need to make sure on whatever external equipment you're connecting to that your settings are set up the same on both machines. If there's a recommended setting that's recommended for that hardware, you can specify that in the Experiment Object Devices tab. So if you needed to use a different bit per second, you can specify that as there to match the recommended settings for that device. And the second approach, which we already covered here on sending a serial signal, is to send the signal after the stimulus is presented. And this does require pre-release, so you're not just sending it at some random time and causing onset delays. And we already spoke of what pre-release would do there. You do want to be careful when pre-releasing certain objects. For instance, if you did have this inline here, but you didn't want it to process while the feedback object was being presented, you want to make sure that you set pre-release to 0. And you also want to make sure that you don't pre-release your stimulus object into a feedback object, because this could just mess up what E' will show you for the correct answer or incorrect answer. So if you had stimulus with a duration of 1,000 milliseconds and the pre-release the same as duration, this would allow the feedback display to process while the input mask or the stimulus object is still processing. So this would show you the incorrect feedback since it's already loading the feedback display prior to the stimulus object being terminated. So that's one thing to be careful for when using pre-release. And a nice feature about the E' 2.0 Professional is the Experiment Advisor. In situations where you wouldn't want pre-release to happen, recommended settings and changes to your experiment will be advised in the bottom in the output window, which if you go to View and then Output would appear down here. Now you won't see the Experiment Advisor module in my experiment since I chose to keep this one standard. And you can also use, if you want to synchronize, for instance, say your signal to display within one refresh of the onset of fixation, in this case, you can add a display.wait for fixation, or wait for vertical blank, I'm sorry. And this will allow you to cause a refresh, and at the vertical sync, it will then send the right string. And this will allow you to have accurate values sent within one refresh of the fixation object onset. And this may be a more consistent method of sending a signal. You would just need to test it onto your machine to see which works best with your current setup and configuration. The downside of this approach is that still the object could have a variable duration, and you could have slight variations when the signal is actually sent. and this is especially true when using pre-release to send your signal. If you're using an object that is using large images or a lot of data being shown on the screen, such as a video, the loading times can vary from machine to machine, and this delay would be reflected in your output to your external equipment. Do we have any other questions?
So far, no. But if you have any questions, just let me know. Oh, we do have a question now. Let's see. Oh, just someone is requesting the all the files that were sent out. So we'll make sure that you get everything that was discussed today, as well as a list of any questions that were asked and their answers. So I'll make sure to get that mailed out to you. Well, emailed.
And included in the documentation that I sent out, if you look at the events charts and properties charts, the events charts here pretty much list every single property for an object in task events, from the finish time to onset time to max count reach, and it also gives a description of what every single one of these will do and basically when you should use it. So this will give you a better idea of how you want to send your trigger out and when, and this is just a nice little reference guide to use here. And the properties chart is also used with task events, but you'll see the same values are used for using eBasic scripting, and that's just, sending, for instance, a write string, and just a brief description of this. So if you ever need a quick reference on what you need to send and how to send it, you can refer to these two documents here. And for more information, you can always go on our support site at pfcnet.com/support. If you haven't already registered, all you need to do here is just enter your email address and password. You will need to use your serial number to register. And once you're registered, you'll have access to our knowledge base, download samples, and you can open a support request if necessary. If you're receiving error messages or need help troubleshooting an experiment, you can always create a support request, and we'll be more than happy to help you there. And you could always find more information on, for instance, what adapters we approve for our serial to USB. And we have our brands here listed with timing information as well. And I have a sample here of what a support request would look like. Essentially, what you would do is you would create a support request, and we always ask that you attach your experiment files and appended files along with a brief description of the issue, and then we usually get back to you here. Well, I shouldn't say we usually get back to you here. We will get back to you.
We absolutely will, yes.
And do you have any other questions?
Is this the official, wide-open question and answer time? Anything on your mind? Anything E-Prime related? You want to ask about the weather in Pittsburgh, which is always stormy when we give webinars.
We never know.
Yeah, any questions, just let us know. All right, so so far I don't have any questions over here. So I guess we could always answer any questions via any of the methods that we described, so the support site or emailing us or anything like that.
Okay, and once again, we'll go ahead and get any information sent out to you guys if you didn't receive it, and feel free to create a support request on pstnet.com/support. And I would just go ahead and make sure that you get all of these here for reference, especially the event chart and properties chart if you're using task events. I also included a summary of how to use and a tutorial of task events. This includes a general overview, a how-to video, and how to choose the communications that you would like to use. And this is just a great brief summary overview of things that I covered here, along with a video too, if you'd like to go and watch that. So basically, I'm just pushing task events there. And I guess this wraps it up. Thank you.